maths because it was not possible to read gem at all. Here, so at every point, I'm just seeing the blocks before and not the blocks after that.
Right.
Right? So I will traverse the entire thing once and then check. So, but it is also possible that the minimum can be from my right end, right?
Solve it. Oh, and in the last 10 minutes of the video, we did a feedback session to cover Kirti's performance, so you don't want to miss that. Hi, Kirti, how's it going? Are you excited for this interview?
I'm very excited and very nervous.
Okay, well, try not to be nervous or try to let the nerves fuel you into acing this interview. And I'm going to put the timer on the clock now. We're going to have about 45 minutes, and I'll let you know, when we're running out of time or if we have to speed things up. Okay?
Sure.
All right. Starting the clock now. So, Kirti, I want you to imagine that you're about to move. So maybe you're moving to a new location and you want to find an apartment that you want to live in. So imagine that you have one street, and the street, you can imagine that it's on a single line. So imagine, a single line here in this drawing. I'm just typing a bunch of ones to show that it's a single file line. And at each block in this line, there's an apartment. So you can imagine that I'm probably going to give you a list of blocks, street blocks, and at each block or each index, there's an apartment that you might want to consider living in. Are you following me so far?
Yeah.
Okay. So you want to make sure that the apartment you live in is really good for you. And the way that you're going to determine if it's good for you is if the apartment is close to some buildings that you really value. So for example, you really value, or you might really value, being close to a gym, or being close to the office, or being close to the supermarket. Does that make sense?
Yeah.
And so I'm going to give you information about at each block whether or not there's a building like an office or like a school or a gym, and you're going to want to find the apartment that minimizes the farthest distance that you would have to walk to get to all the buildings that you value. So I realize that I've given you a lot of information. I'm going to show you a couple sample inputs just so that you have an idea. So imagine the first sample input is going to be called blocks, and it's going to be a list, let me put it like this, that has a bunch of objects, hash tables, so to speak. And these objects have all these buildings that map to Booleans. So here at index 0, you can see that there's a gym.
Tinder double date, now let's friends not in chat as a pair. So I have to pick my funniest friend. Only a woman instead because I am feeling chemistry. Wait, how did you get that decision here?
That's really fucking plus. That's this really power gone. I'm stuck on that's really fucking plus.
There's a gym that maps to false, meaning that at block 0, there is no gym. But there is a school, but there is no school. At block 1, there is a gym, there is no school, and there is no store. Does that make sense?
Yeah.
Okay, and so then the second input that I'm going to give you is going to be a list of required buildings. So if I go a little bit lower here, I'll put reps, requires, or requirements. And this is going to be a list of strings. And this list of strings is going to have the buildings that you value. So here, you happen to value gym, school, and store. But I could maybe give you just like gym and school, or I could give you just gym, right? It could be any buildings, and they don't necessarily have to be in these objects. And so here, if you value gym, school, and store, that means that you have to find the block that has an apartment. And by the way, every block has an apartment. The apartments are kind of implied to be at every block. You have to find the block that will minimize the farthest distance that you would have to go to reach all of your requirements. And so here, for this sample input, the answer would be index 3, which would be this one. If you want, I can highlight it, let's say, in light green, here, this one. Because for this one, the farthest that you have to walk to get to all your required buildings, the gym, the school, and the store, is a distance of 1. Because the school is right here, then a gym is 1 above, and then a store is 1 below.
So can there be only 3 things, that is gym, school, and store, or there can be more number of things?
There can be any number of buildings, and the only thing is that in the blocks, at each block, you will have information about every single building. So for example, if I were to add here something like, I don't know, office, then you could expect that every block would have a data point about an office, whether it's true or false.
Okay. And it will be a valid input, so I don't have to check whether all 4 are present or not, right?
Yeah, you don't have to check whether all 4 are present.
Okay.
They will always be present.
Okay. Okay. So at the top of my head, if I have to talk about root cause solution, so I can consider each block to be my solution, and I can just keep calculating the distance from them, right?
Okay.
So suppose I consider that my apartment will be here. So if so, like in this case, I can see that there can be multiple things in an apartment. There can be a gym as well as a school, right?
Yeah.
Yeah. So distance will be 0 plus 0, like that. So I will keep calculating the minimum distance as I traverse the array, and wherever I find the minimum one, I can just return that.
Okay. And just can you walk me through conceptually, like how exactly do you find the minimum distance?
Okay. So suppose suppose the requirement was just gym and school. Okay. So I come over here.
Okay.
I have the number of variables that are there in requirement. So same number of variables. So right now I'm going to keep 2 variables. That is the distance for the minimum distance for gym as well as the minimum distance for school. And there will be a result that I will store. That will be the minimum of sum of both of them. Right. That is my minimum result that is possible. So when I'm here, so I will have 3 variables. So one will be distance from gym. So gym distance. Then there will be school distance, and there will be resultant. That this will happen minimum value. Okay. So here,
Okay.
since this is false, my school distance will become 1, and this initially will be some maximum value, say infinity or max, and so this is infinity and this is 0. Right. Then I come over here.
Okay.
Here gym is uh, here gym is true, so here the gym distance becomes 0. So since I traveled 1 distance, so it will become sort of the resultant from the previous one plus 1, right? So it will be distance of this plus 1, and then I will keep checking whether the resultant has to be updated or not, right? So the earlier result was max because it was not possible to reach gym at all. Here, so at every point, I'm just seeing the blocks before and not the blocks after that.
Right.
charge you with that.
Right.
right? So I will traverse the entire thing once and then check. So, but it is also possible that the minimum can be from my right hand, right? Like instead of from my left hand, can be from right hand as well. So probably what I should do is traverse the array twice, one from the left side and one from the right side, and then check that what is the answer.
And just before you keep walking down that path, Turkey, just to be clear, you're looking for the minimal farthest distance that you would have to walk to, right? Because, so for example, like at index 3 here, which was the answer here, the farthest distance that you would have to walk to was still 1. Even though there was a school here, which was 0, you would have to walk 1 to get to the gym up here and 1 to get to the store down here. Does that make sense?
Can you please repeat that one?
Yeah, so since you have multiple requirements, or you might have multiple requirements, you want to minimize the farthest distance or the greatest distance that you would have to walk to. Because here, if you care about gym, school, and store, school is 0 distance from this index, right?
Okay.
But gym, you have to walk 1 to go up here, and store, you have to walk down 1 to find it here. So the point that I'm trying to make, that I just want to make sure you're clear with, is that it's the farthest distance that you have to go to that you're minimizing, not just any distance.
Okay, so it was not, so, okay, I understood it wrong. I understood that it was the sum of the distances. It is not like that. It is like farthest for anyone that I have to go, right?
Yes, exactly. It's not the sum. So
Okay.
even though the sum here is like, I guess 2, it's not that we care about. It's the farthest that you would have to go to.
Okay, so it will be like, so I will have to minimize the max of gym distance and school distance essentially.
Yes.
Yeah. Okay.
That's one way to put it.
Yeah. So I have to minimize the maximum value among the requirements. Does that sound fine?
Yeah, I think that sounds good.
So basically, I will have I can have a hash map sort of thing, an ordered map. So corresponding to each requirement, I will keep the maximum distance, right? So and I will minimize that because okay, so corresponding, so okay, I have to keep that. Okay, so for the entire array, just give me a second. For the entire array, for each block, I need to minimize the maximum distance. So for this, suppose I have to calculate the maximum distance, I will have to, so that will become order of n square. So now glucose will become order of n square. So if I have to, for this block, I will have to check the maximum distance of all the other blocks, right? Similarly, for this block, I will have to check for all the other blocks. So to minimize that, to make it order of n, I will have to use dynamic programming and store the values in this array. So if I have say dp array of distances, so this will again be it will be sort of array of vectors. So and vectors will be the distances, the max distances for each of the requirements.
Okay.
Right? So it will be like, so suppose there are n blocks, right? So this,
Yeah.
Okay, this auto, this thing I'm not really caring about it, okay?
Okay.
Yeah, this capture. So I keep a DP array of size n, suppose, okay, and each of them is a vector. So it will be vector of vector of integers, say dp, and this the entire size will be n, and each vector will be of the size, what will be the size of requirements. Okay, say that is
Okay.
in this case, and we will initialize the whole thing to some maximum value.
Time to restock. The Smiths app offers the same great prices and quality for pickup or delivery. Pampers Swappers keeps baby 3 times drier. So your baby stays comfortably dry all night long. Pampers Swappers, dry all night.
Does this look fine?
Okay.
So now as it travels, can I just start at least sudo code and then we'll keep discussing?
If you want, but just to make sure I follow you, could you re-walk me through like what the logic you're about to write in pseudocode is?
Okay, so this is the array of vectors that I'm storing, right? So as I traverse this array, for each point I'm going to keep calculating and like I will see all the answers previous to it and update it. So if like the maximum distance of this school should be the maximum distance of the previous one plus one, if it is not present over here, right?
Okay.
So it basically I am calculating maximum distance for each requirement for each block in the array.
Yeah.
Does that sound fine?
Yeah. But how are you doing? You said you're doing that in one iteration.
It will take 2 iterations, I think. So one will be I'll go from left to right, and one will be from right to left.
I see. Okay.
Does that sound fine? And I take minimum of it.
Yeah, I think I'm following. So if you want, you can read the pseudocode that you were gonna write.
Okay. So I'll just write it in simple terms. So I will do zero I less than n I plus. So I'm traversing the entire array right now, and for each element I have to track for all the requirements, right? So for n equal j equal to 0, so j less than n is the size of the requirements over there, right?
Yeah.
So plus, and so what I'll do is, if it is the first one, so for the first one I will update over here. So I'll traverse this from I equal to 1. Also, can I assume that there will be at least one element, or should I handle cases when there is just one block or two blocks?
Let's assume that there's always. Let's assume, for simplicity, that there's always at least one requirement and one block.
Yeah. Okay. So in that case, so this is for my first block. Okay. So for first block, as I go through this, so if these are the blocks given to me, so if blocks of 0, that is the first block that I'm seeing, if the element, so I'm just saying it. So can we say that input is given in terms of the requirements? So 0, 1, 2, or should I say this thing like should I pre-process this thing and save it in a array sort of thing? So basically, what I'm trying to say is that for block 0, this is requirement 0, this is requirement 1, this is requirement 2.
I see. I had the requirements as a vector, a string vector. But if this is simpler for you, you can assume that you've pre-processed it, map the requirements to numbers if that's easier for you.
So would you rather have me write the pre-processing code as well, or is it okay to go like this?
For now, let's assume that you've written it. So just to understand, you're saying that basically your requirements now look like this.
Right. And
Right.
I can just map it to 0, 1, 2.
Yeah.
It will
And I'm
just
assuming
be,
that you would do the same for the blocks, like the unordered map
Yes.
here, the keys in the unordered map.
yes. So this will be an integer and this will be a boolean. So boolean and integer.
Okay.
That's fine.
Yeah. Let's go with that.
Okay. requirement, jth requirement, then what I do is I update that distance. So dp of so otherwise it will be in months, right? So otherwise, so for this one I update dp of 0 j2 0. So the distance is 0 for this one. Okay.
Okay.
Does this seem fine to you till now? So this is for the first block.
Yeah. But you've only done it for the first block.
Yes. So for the rest of the blocks, so I'm starting from I equal to 1, I less than x. So here, so for rest of the blocks, what I'm doing is, so dp of any ith block, and for each j, what I'm going to do is, it will be equal to, so I have to find the maximum, the farthest that I have to go, right? So it will be, so the farthest that I have to go. So if, first of all, I will check if that one is true. So if blocks of ij, that means if it is present over there itself, then I can just assign the dp of ij to 0. That means
Okay.
that thing is present over there. If it is not present, what I do is I check if it was present somewhere earlier, right? So for this, so what was the distance for the previous one? Plus 1 it will be, right? Now, it is possible that we haven't found the previous one, so the value will be in max over there. So if I add plus 1, it will go out of that, right? So I will have to add a check over here that if dp of I minus 1j is not equal to int max, right? Then
Tinder double date lets friends match and chat as a pair. So I picked a friend who always hypes me up.
Look how kind she is, leaving plenty of pins for the rest of us. Thank you.
then my dp of ij will be equal to, so minimum of whatever is the value. So if it is max now, so I won't have to consider it, or if it is 0. So minimum of dp of n minus 1 plus 1. Does this seem fine?
Yeah.
So this is for, this is fine when I'm going left to right? So for each of them, I am updating that what is the maximum distance that you have to go, right? Now, with this, instead of doing this, I can do one more thing. So I keep this as 1 n plus 1 instead of n. So the last element that I'm going to store will be the it will be the minimum of all these values. So this is like the maximum distance that I have to go, right? So I have to minimize the farthest distance that I have to go for all the blocks, right? So for each block I have to find that. So for each dp of I, basically I'm storing one more element which will essentially be maximum of all of these distances for that block, right? So when I'm calculating this, so for each of them, right? So there is this in here. Yeah. So after each this, so dp of instead of this, yeah, over here I can have, so dp of I m will be equal to maximum of so initially it will be okay. So for each of them I have to add dp of I m as some 0, right? So we can assume that at least, so I have to find the maximum distance, right? So if that value is maximum initially only, then anyway it will always be max, right? The answer will always end up being max. So So I initialize dp of im as 0, and I'll make this
Right.
as dp of im and dp of ij. So whatever value I have calculated, if that value is greater, then I have to have it. So I'm storing the maximum value over there. Does this make sense?
Yes. Yep. You're updating at each iteration the maximum net distance of the requirements that you found.
Exactly. Right?
Okay.
So I have done this when I'm going from left to right, but the maximum travel distance can also be from right to left, right?
Yeah.
So I will have to do the whole thing, like the same code I have to done in the other direction as well.
Right.
Right? So now what I do is, for n I equal to n minus 1, I greater than or equal to 0. So I can just copy this whole thing and make some small changes.
Yeah.
Right? So for dp of im, I don't have to update it to 0 now because some value is already there. I don't want to discard the value. Right?
Right.
So now again for each block, I will check. So this will remain same. Now instead of I minus 1, I'll make it I plus 1. And instead of n minus 1, I'll go from n minus 2. And it should be greater than or equal to 0. And it will be max of this. So yeah, I think this should work. Can I dial
If you
in and
want.
check?
I'm sorry.
Can I just dial in once and check? Or do you have any questions or does this seem fine?
Yeah, I was gonna say, could you walk me through, like, let's take the sample input that we have above with Jim, school, and store, and we can assume that I guess Jim is 0, school is 1, and store is 2.
Okay.
And walk me through the algorithm, like basically iteration by iteration, just to see that it works
Okay.
conceptually.
So I'll just store the dp values over here, right? Okay. So dp, so for like 0th value, what will be the values initially? If so instead of writing int max, I'm just going to write some big number 100 for now, right? So that will be easier to understand.
Yeah, or if you want, you can put like just like an asterisk, or like a single character like this.
So for dp of 0, so first we'll go through this one. So only for store it will be true. So it will be something like
Golden Oreo cakesters. We decided to show off our sauce. Got pet owners? Get the free fabulous range to keep your fabulous smelling fresh and clean.
asterisk, 0 asterisk, and the last value will be asterisk itself. Okay?
Because the last value you take the maximum
Yeah,
of all
yeah.
three of these.
Yeah. Okay. So also, okay, so here this is the tricky part. I haven't taken care of resultant, which will be the maximum of all these dp of IM essentially. So we can calculate that. Okay. Let's first see if the rest is working or not. So dp of I1.
Yeah.
So I come over here, I put dp of IM as 0, that is okay. So for each block, I check if it is true, okay, otherwise I'll add the distance, okay. So here, since this is true, this distance is going to be 0, right? Now this is false, so this will be either int max or this plus 1. So this is going to be 1, and the distance of store is going to be this plus 1. So here, since it was max only, I'm going to keep it max. And dp of IM is going to be max of these all. So since this is asterisk, so this will also be asterisk. So the maximum distance is infinity itself right now.
And just here, stop you for 1 second, just to make sure that we're on the same page. So here you're effectively applying this line, right? I just copied the line that you had written,
Yes.
right? And so at the second element, you took the minimum at that element, was int max.
Yeah.
And dp of I minus 1 at j, which was this 0 here,
Yes.
plus 1,
Yes. So
and
0.
then, yeah.
Right.
So it was min of int max and 0 plus 1.
Yes.
That makes sense.
So now coming to the second element. So if I am here, so here the values are going to be, since this is true, it is going to be 0. And this is also true, so it will be 0. And since this is false, it will be minimum of either int max or int max plus 1. So this is int max, so again the value is maximum only, so this will again not get updated. Because the farthest distance till now is still implemented, right? Now if I come over here, it will be, so here the gem is false, so it will be either 0 or it will be either int max or 0 plus 1. So in this case it will be 1. Here it is true, so store is true, and store is again false, so this is again infinity. Okay. So
Yeah.
for 4 again, so this is false, so it will max distance will be 2. Here it will be 0, so store is so 0. Okay. So here this is true. So what I'm going to do is this will finally become 0, and our dp of im will be equal to max of dp of im and dp of ij. So what is the maximum value of all of this? Oh, sorry. Yeah, what is the maximum value of all of this? It is 2, right? So the farthest difference for all of this is 2 in this case.
Yeah.
Right?
And this this line, just again to make sure that we're on the same page. It's this line, so
Yeah.
dp of I, which is an x4 at m, is this value is the maximum of dp of I of m, which was int max, because you've initialized it to int max.
Correct. Yeah.
Yeah. And then oh yeah, because you've initialized every single value to int max. Is that how what this does here?
No, but I also initialize dp of im to 0, right? So this value
Oh, right.
is
Oh, you initialized it to 0.
yeah, yeah, yeah.
Okay, so max of 0, sorry, so max of 0 and dp of I of j, this would be, like basically at every iteration you do max of 0, 2, max of 2, 0, 2, 0, and
Yes.
end up with 2, right?
Yes, yes.
Okay.
So in the second iteration, so this answer will remain same, and I'm going to start from n minus 2, which is this one. Okay, so I start from here. So gem value was initially okay. So since this is false, what I'm going to do is I'm going to take so I'm over here, right? So it will be either minimum of what is there or dp of I plus 1j. So either minimum of 1 or minimum of 2 plus 1, which is 3, right? So in our case, we won't update it. So this is going to be 1 itself, right? Now since the store is true, this will be 0. Now again, this store distance will either be this or 0 plus 1, which in our case will be 1. Does
Yeah.
that make sense? Yeah. So now the answer, the dp of I dp of I n for this case will become 1 because the maximum distance is 1.
Yeah.
Right. So in the end, I will return the minimum of all of these dpins, right? So minimum of 2, 1, like that.
Yeah.
Right. So in this, so again coming over here, so here gem value is 2, so it will be 0, and this is also true, so it will be 0. Since this is false, here it was infinity, so it will be minimum of 1 plus 1, which is 2. So answer will be 2 over here. Make sense?
Yep. Makes sense.
Shoppers get up high quality and down low prices. Smith, fresh for everyone. A diaper instantly free, substance free. Only Pampers Cruisers 360 have a 360 stretchy waistband for up to 100% leak-proof fit on every wild child. Pampers Cruisers 360, now with a new low price.
1 second.
Yeah, no problem. Take your time.
Now 0, so this is okay. Now either the distance will be 1 or max of 0 plus 1, so it doesn't matter. So this is going to be 1. So either infinity or 2 plus 1, which is 3. So here it will be 3. Now again over here if we come, so the gym distance over here was infinity. So here it will be 0 plus 1, which is 1. Here it is 2, so it will be 0. So 4 and max of all of these 4. Right, so now I have to return minimum of 4, 3, 2, 1, 2, which will be 1. So this will be our answer.
Gotcha. And just to be clear, can you remind me the reason that when you go from right to left, you skip the final index? What's the logic behind that?
Because essentially I want to see the distances from the right? So this is the rightmost element. So like there is no element on the right. So this is like when we calculated from left to right, I did not calculate for zeros, right? So I already
Yeah.
some pre-calculation. It is similar to that. But since some calculation is already done over here, I don't have to do it separately, just that.
Yeah, makes sense. Okay, makes sense. And so I guess as a final few things for the finding the minimum index, just walk me through out loud what you would do.
Yeah, so
You
here
just-
just I can just keep a result, right? And here every time I calculate PPFIM, so I don't have to get the result in the first iteration since anyway I'm going to do it again, right? So my result will be equal to minimum of result and PPFIM. So this is when I'm going back, when I in my equation from right to left, then I'm going back, I calculate these values. So, okay, when there is just one element, this will not work because in that case, I am not calculating BPF item at all. This will be at least when there will be at least 2 elements, right? So when there is just one element n equal to 1, I will have to return the, so for this one, I should calculate, I haven't done BPF item for the first one, right? So BPF
Yeah.
will be equal to essentially this. Right, so my resultant here I can just store result equal to BPF. So this is just
Right.
for the case when there will be one element.
And plus, I mean, in the case when there's one element, I guess I could have specified that maybe the input just always has 2 elements rather than one, because
Yeah.
there's only one apartment that you could go to, so it doesn't really make sense. But good that you caught that. Could you walk me through the time and space complexity of this algorithm?
Yes. So for each block, I am going through all the requirements, right? So if this is, so there were n blocks and n requirements, so the time complexity will be order of n over there also and over here also. So it is order of 2 into n, which is essentially order of n. And the space complexity is also order of n, since I'm storing the requirements for all of them.
Yeah. Okay. Great. And this is better than the brute force solution that you alluded to at the very beginning. Although I think at the beginning you were doing the minimal distance of the sum, but you were still alluding to a brute force solution.
Yes, yes. Well, were you expecting a better complexity solution or is this okay?
No, this is great. Just maybe as a final thing, because we still have roughly 10 minutes here, but as a final thing, just out of curiosity, how would you, if you had to, do you see ways that you would improve this code, maybe from a code perspective, because here we sort of did pseudocode, part real code, part pseudocode, but how would you do this if you had to write the function signatures and things like that?
So obviously I'm not taking correct naming conventions. I just taken IEG and written not at all professional way. So the naming conventions I should definitely change. Like I have taken vector of vector and I've called it DP, which is when a third person is reading, it doesn't really makes sense, right? So maybe I could have named it requirements distances and uh, like similarly naming conventions for items I could have definitely done better. And
Now friends can watch and chat as a pair. Try Tinder Double Date today. Manuscripts were recorded, so you can make your space your own. Command do now.
return it in total.
Okay, cool. Well, listen, Kirtan, I think this is great. Super quick commentary. As we're about to see in the last 10 minutes of the interview, we did a second code question. And in hindsight, I think that was a mistake from me, the interviewer, because I had already gotten really good signal about Kirti's algorithmic skills from the first question, but I hadn't gotten the best signal from her coding ability because I didn't see her code in a sort of production grade formal quality. She even told me herself that she would rename certain variables and things like that. And so in hindsight, I think that instead of doing a second question where we only had 10 minutes, I knew that we weren't going to get to the coding part, so I effectively just reassessed her algorithmic skills from a conceptual point of view. I think that I would have been better off having her rewrite her code in a more production grade quality, in a more formal grade quality, and that would have given me more signal about her coding ability. That was my mistake in hindsight. Anyway, I'm telling you now, and enjoy the rest of the interview. But we still have roughly 10 minutes on the clock, Turkey. But we're going to do something completely different. We're going to switch gears. When you're at a big tech company and you're on an engineering team, you often care about, or almost always care about, the state of the code base, and specifically that all the continuous integration tests and unit tests that are running in the code base, that they're passing, right? You don't want tests to be failing. And sometimes when engineers push code into the main repository, they break the tests. And so the tests start to fail, right? Does that kind of make sense?
Yeah.
So what we called it on my team at Google was the build. So the build referred to kind of like, whether the code in the main repository works correctly, compiles, all the tests are passing, and if everything worked well, you would say that the build was green. If everything didn't work well, if there was maybe like one test that failed, you would say that the build was red, or there was a build failure, okay? So I'm going to give you some data. It's going to be a list of lists of booleans. It's going to be something like, let me copy paste something for you here. It'll be something like this. This is going to be question number 2. And what this is going to represent is each list here. You can imagine that the value at a specific index represents like 1 hour or 1 unit of time. And if this is true, it means that the build is green. So here, the build was green. Then the build was green the next hour. Then it was green again. So everything was passing. And then suddenly, it was false, meaning it wasn't passing, it was broken. And then for another hour, it was false. Okay? Now, when this happens, an engineering team isn't happy. You want the build to be green, so you immediately want to go and fix it. And so that's why you see that immediately in the next list, it's been fixed, and it's back to true, until it goes to false because it's broken. And then an engineer has to fix it, you go back to true, right?
Okay.
So we call these lists here that are effectively like the build is green, and then suddenly it breaks, and then it gets fixed. We call that a build run. Okay? And so what we care about as a team is to effectively like minimize the time that it takes to fix build runs, right? We don't want build runs to be false or to be broken for a long period of time, okay? So we want to minimize that. And what we care about as a data point is something that I'm going to call a green percentage, which is effectively within a build run, the percentage of time that the build was green versus broken. And so the longer or the greater the percentage, the better. So it's like, for example, here, in this particular array, you can see that the green percentage is 80%. Meaning the build was green 80% of the time, and then it was broken for 20% of the time before it got fixed again. Okay? We want that to be as high as possible. And specifically, the algorithm that I want you to give me is I want you to take in this list of build runs, okay? And I want you to return the greatest number of consecutive build runs that have a strictly decreasing green percentage. So it basically tells us the longest period of time during which our engineers were increasingly slow to fix broken builds. Does that make sense?
The first time you tried out, it makes your logic feels a bit pressure softer. So you start to wonder, if you shoot a bounce on the final side, will it make more softer? Bounce can't do it all. But for better laundry, machine
Try dumping documents from nature. The number one font is recommended by Vanessa on the front.
Does that make sense?
I have a question. How come the sizes of the list are different? So, like, are we building different projects all the time, or is it because if it is the same project, then the number of hours taken to build is same? Or
No, because you could imagine that these represent hours. So basically, it's like, okay, for a single code base, the build was green, 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 and then it broke. It broke for 2 consecutive hours, and then as soon as it got fixed again, we represent that in a separate list. And so this is all like the same code base effectively, but here it's green, 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 then it gets broken, and then it gets fixed. So here the green percentage of here is 60%. Then it's
you
80%.
just about the percentage and not about like the number of hours or anything. So because
Doesn't matter the number of hours.
okay. Any other thing in the question you would like to add, or just
That's it. And so we want the greatest number of consecutive build runs, so consecutive lists like this, that have a strictly decreasing grade percentage. And since we are running out of time, ideally just walk me through, if you can come up with an algorithm that solves this, conceptually how you would do it. You don't have to write any code for now.
since it is supposed to be consecutive, so this essentially is a longest decreasing subarray sort of a question, right? So you have to
Okay.
find a subarray because it is consecutive, right? So
Yeah.
if it didn't have to be consecutive, it could have been subsequence, and I could have just said longest decreasing subsequence, right? And we could have done
Okay.
like a normal dynamic programming over here. Since this is consecutive, there are subarrays, so I can just keep 2 pointers over here, and so there will be 2 pointers. One will be left pointer, one will be right pointer. So from left to right, the percentage should be strictly decreasing, or should it be less than equal to condition?
Let's do strictly.
Okay. So so I will move my right pointer and check that okay, if it can be added to the answer to the left to right, if it is less than the right element that we had earlier, then I'll just increase the length to 1. Otherwise, I'm going to update my left pointer and then calculate again, and I will have a result over here. Does that make sense, or should I just write
And
it?
here, when you're saying from left to right, you're saying you have one pointer at the left of the main big list, so that starts right here,
Yes. So the
and
left is essentially 0, and my right is also initially 0. Okay. So what I do is that if so I will keep doing that. I will basically move my right pointer, right, and then I will check that if the percentage of right is less than percentage of right minus 1, because I just moved it, right? So
gotcha.
I can,
Okay, good. Sorry to cut you off, Ricky. So I understand now. How are you going to be calculating the percentages?
yeah, so that I can preprocess and keep, so the number of trues and number of false we have to go through the entire list at least once, right? Because to check how many were true, how many were false. So yeah, I'll have to walk through at least once.
If I tell you that they always start as the build runs by definition are always true and then they turn into
Okay,
false.
okay. Then I can just do a uh, lower bound which will return me greater than or equal to, or I can just do a binary search that is the lower bound, essentially the first case where it was false, right?
Right.
Yeah, so
Yeah.
it's called
Okay.
binary search. So I can calculate that in log n if n is the size of the list, and yeah, so log n to find the percentage. So I will have the first case where false came. So the ones before that were true, and we know the size of the list, so we can calculate the percentage.
Right, exactly. And so then the total time complexity of your algorithm would be
So I would have to travel this entire thing once. So and so if say m is the maximum size of the list and n is the number of lists, so it will be order of n into log n.
yep. Okay. Great. Listen, we're out of time now. We're exactly at 46 minutes.
Okay.
So I think this was great. We covered at least conceptually so a second question. I think we can jump into the feedback now.
Okay.
Okay, cool. So I'm going to stop the timer. So for the feedback, I'm actually going to send you a link of the feedback form that we have on our mock interviews on Outlook.
Time to restock. The Smiths app offers the same great prices and quality for pickup or delivery.
Is that I would agree with Katie in demand, but some degrees are more valuable than others. Take cybersecurity. There were over 3.5 million unfilled cybersecurity jobs globally in 2021 alone. Stay in demand. Earn your cybersecurity degree from WGU.
Our expert, which is actually like very similar to the feedback that you would get at Google. So at Google, there are here I'm making myself off of Google, but this is very similar to most big tech companies. But at Google, usually there are these four main categories that you assess on, like algorithms, coding, communication, problem solving, and a few other things. But these a few other things are kind of intertwined. Things like how you handle curveballs or ambiguity, or where you was there any moment where you were like disrespectful or you didn't react well to stress or things like that. But here we're going to focus on these four main things. So I think that for algorithms, I would definitely give you a 4, which is the best score here because you for not only the first question but also the second question in very little time you came up with the optimal algorithms to solve the question. You basically had no help from me in both of them, and you clearly demonstrated that you know how to work with algorithms well. Right? Your dynamic programming is on point. Binary search, you got that right. So really, really well done there. Then, if you want, we'll jump down to problem solving before covering the other two, because problem solving is often pretty related to the algorithms. And here I would probably also give you a 4 for the problem solving. Maybe I would hesitate a tiny bit with the 3, just in the sense of like, maybe there was room for, you could have asked a tiny bit more clarifying questions, because at the beginning, you were going down the path of, minimizing the sum.
Yeah.
But like, that is, personally, I don't really find that as that big of a bad thing. This was a complicated question as far as like the amount of information I gave you. And otherwise, I think you just approached the problem well. You covered, you talked about edge cases. You asked about like, what if it's an empty array that has one element? You can handle the case with one element. And you covered a little bit of the brute force solution at the beginning. So overall, yeah, the problem solving was really on point there too. So I'd give you probably a 4 there.